Good morning, students. Welcome to the first class on quantum mechanics. So we'll give an idea about what is quantum mechanics. For that, we have to have an idea about the development of quantum mechanics, history of development of quantum mechanics. So for developing quantum mechanics, we have to have a clear picture of classical mechanics, which is dealing with the macroscopic bodies. Classical mechanics is a branch of science which is based on Maxwell's electromagnetic wave theory and Newton's laws of motion to explain various phenomena related to energy and motion. It is also known as Newtonian mechanics since it is based on Newton's laws of motion. So for every large-sized particle, we can apply these laws and it is found to be successful in explaining all the properties. For example, the motion, velocity, momentum, acceleration, etc. can be easily calculated and predicted using Newton's laws of motion. But when we come to smaller microscopic level of particles, just like electrons, atoms, molecules, etc., it is found to be a failure in explaining the phenomenon. For example, in the case of a moving particle, we can determine the position of the particle and velocity of the particle simultaneously by classical mechanics. But when we come to a subatomic particle like an electron, it was found to be not possible to determine simultaneously and effectively both the position and velocity of a particle. Another phenomenon is that the emission of energy. Classical mechanics shows that energy is emitted or absorbed continuously. But in the case of subatomic particles, radiation is not found to be emitted continuously, but it is discontinuous. So there are certain phenomena which classical mechanics cannot explain. The first one was discontinuous emission of radiations by the excited atoms. Another one was the spectral distribution of energy, or the explanation for the various radiations emitted by the black body. Another one was photoelectric effect, which cannot be successfully explained by classical mechanics. Compton effect is another phenomenon, which is the increase in the wavelength of light which is scattered by the electrons. All these phenomena was not successfully explained by classical mechanics. So it was a need to develop a new branch to explain all the properties related to the microscopic particles, subatomic level of particles, and that is what is known as quantum mechanics. So before studying quantum mechanics, we have to have a clear picture of what are the failures of quantum mechanics. So first in this class we will be dealing with the first failure, that is the failure for explaining the black body radiations. So what is a black body radiation? You know that what is a black body? It is a particle which absorbs all the radiations of all frequencies and wavelengths falling on it, and it will not reflect any of the radiation falling on it. So it appears black because it absorbs all the radiations falling on it. And such particles are called black bodies. And one of the black bodies was made by a scientist known as Fermi. he made a black body which consists of a hollow double-walled metallic sphere having a narrow opening on one side, and it also just opposite to the small opening in the inner side of the body there will be a conical projection which uh, reflects all the radiations falling on it. That is, the any radiation entering the black body through the opening will fall on the conical projection and it gets reflected in all the directions, and after multiple reflections at its inner walls almost all the radiations are found to get absorbed by the surface of the body. So such a black body was developed by scientists. This is the black body which is having a hollow. It is a hollow double-walled body. Inside is hollow. This is a small opening through which it enters, and here inside the body there is a conical projection which is able to reflect all the radiations falling on it. And these radiations will be getting reflected and absorbed by the inside of the body. Okay, so this is a black body, and what is the another feature of a black body is when we heat a black body, it will start emitting radiations, and the radiations emitted by a perfectly black body is known as a black body radiation. Okay, then there are certain features for the emissions of black body. We can see that it emits radiations of all possible wavelengths. That is, we are starting heating the radiation, and at lower temperature, we are getting radiations lower in energy. For example, falling the radiations which are falling in infrared range. But as the temperature increases, the energy of the radiations emitted increases. That is, they will become shorter and shorter in wavelength. So that is observed by a change in color of the radiation emitted. It changes its color from red. So first it was longer wavelength and lower energy. So red color was emitted first. As we heat the body, as temperature increases, it was found that the color of the radiation changes to yellow, to green, etc. So there is a change in color. So we understand that the energy radiated is not of a single frequency or wavelength. There is a change in the frequency of the radiation, and the relationship between energy density and wavelength at different temperatures was plotted, and we get a spectrum or a peak like this. Here this shows a difference in wave. It shows the peaks at different temperatures, starting from 3500 Kelvin to 5500 Kelvin. And see, at lower temperature, it emits deeper red color. Then it changes to light red, orange, yellow, green, etc. So, after analyzing the spectrum, we can see that for each temperature, there is a particular wavelength at which the energy radiated is maximum. For every peak, we can see that at a particular wavelength, the energy radiated will be maximum. See, okay. Then, with increase in temperature, this maximum shifts towards lower wavelengths. See, here it is. The wavelength is here. It is this wavelength which has maximum energy. Higher temperature it shifts to left side. Again 4500 Kelvin, it again shifts to left side. See, the maximum shifts to left side, or it shifts towards lower wavelength. Then another phenomenon is that with increase in temperature, the position of the maximum becomes more pronounced, more peak. Here it is blunter, but it is more sharper here. So all these are the phenomena observed by studying the black body radiation, and it was a failure for classical mechanics that it couldn't explain why it gives out different colors of radiations or different wavelengths, because wave theory says that it should emit only one wavelength. Okay, so here it was impossible to explain the different variation in color or variation in wavelength emitted by the black body, and so it was found to be one of the most important failures of classical mechanics. So by this we come to the end of this class. Next, in the next class we will discuss the other failures, that is photoelectric effect, Compton effect, etc. Okay.